I0 is the constant, etc. If a gun measures 13.4 B, then what is the sound?
The B is just a unit, so you can ignore the B. It's just a unit, like, you know, meters or something. It's a unit we haven't done in physics. Okay. Right, that's enough time practicing those. That's a very important worksheet. You should really try to get them finished. I know some of them are hard, but it's important for the exam. Okay, we'll go on to a new chapter then. So that was the end of that chapter. Next, we'll start with something easy. The beginnings. You checking your Facebook? It's still going to say 0 friends. I'm sorry. Okay, continue. By the way, where are the rest of the engineers? Where's my buddy Omar? Don't say that. Omar, if you're listening, I care. What's that? Nader? No. And who else? Fuang, I know, is doing that test.
I think that's it.
I got all the engineers. And then
Nader come with me and he went to the library.
He maybe is also studying with Omar then. And business students. No. Well, he was here, I suppose, so half counts. Right. So, to start trigonometry, this first part will look very easy. You know, the way to measure angles is using something called degrees. So, one full circle is 360 degrees. And you know this. Yeah. But we're going to use a different unit now, which the physics students have seen already. A new unit to measure angles. So this is a bit different now. Instead of measuring the angle using degrees, what we'll do is we'll measure the angle by how big this is. So I'll explain. Let's just say this is or, and this is or, and this is theta, and this part here is L. Then we'll make theta equal to L over or. It's how much this is compared to this. This is called, the unit is called radian. So for example, if I draw or here, and then make sure that this length here is or as well, that is said to be 1 radian. So the reason radians are important is because it can link the angle, the radius and the arc together in one formula. But anyways, what we really need to know is how do we convert. So we need to pick an angle where we know what the total length is. So we'll go for 1 full 360 degrees. Now let's use this new formula. The theta should equal the total length. So if this is or, then how much is all of this? Who knows this from middle school? 2 pi r. 2 pi r over r, which is equal to 2 pi. So therefore you get the result that 360 degrees is equal to 2 pi radian. And this is how you can convert between degrees and radians. So if you want a quick way to convert from degrees to radians, to go from degree to radian, you multiply your number by pi over 180. And to go from radian to degree, you multiply by 180 over pi. So this is important because sometimes in the exam they ask you to convert. So make note of that and we'll do an example. Got that? Not yet.
What's that factorial sign?
No, that's actually an exclamation mark, meaning important. Do you have that? This is taking a long time to write down. People up the front? Yes? Not yet. Are we just waiting for you?
No, Yusuf is also ready.
Are you, Yusuf?
Yes.
Alright. Well, while people are waiting, why don't I write down what I'm going to do next? So, as an example, I want to convert 293 degrees. So maybe you can try this on your calculator. What's that in radians, please?
Pi. Oh shit.
Okay, let's have a look at this one. Yes, so it'll be 293 multiplied by which one? Pi or 180 on the top? Pi over 180, which you can leave like that, or as a decimal it'll be 5.11 radians. And then let's do one the other direction, and let's convert 8 pi over 15 radians. If you can convert that into degrees, please. Got this? So, this time, 8 pi over 15 times, and what do I need this time on the top? 180 over pi, so the answer is 96 degrees. Okay, and then just one more of these. I want you to convert 2.7576 radians into degrees. Okay, do you have this one? Yep. 2.7576 times, now I want degrees, so that's 180 over pi. So this time I get basically 158 degrees. Like that. Yep. Okay, next now. Very simple formula which you all know from middle school, but we'll just do it now anyways. Not even that yet. If this is A and this is B and this is C, then Mr. Pythagoras tells us C squared equals A squared plus B squared. But like I said, you did this in middle school. So let's just do one example. Calculate the B for me. Calculate the B. What did you get? 13 squared equals 5 squared plus B squared. So 169 equals 25 plus B squared. 144 equals B squared. So B equals 12. Okay, try this one then. Ugh. Seven 24 x. Get x then. Possibly. Possibly not. But mostly possibly. Yeah, so we have x squared equals 7 squared plus 24 squared, which is 49 plus something, which is 625. So x is 25. Hang on, that's 24 squared. Now, don't tell me. Hang on. 576 is 24 squared. Yes, okay. So x is 25 then. Yep. Okay, so that's Pythagoras, but like I said, you know this from middle school. And something else that you probably know from middle school coming up. So, when you have a triangle, and we call, actually, you know, I haven't told you the name of this triangle. What's this triangle called?
Triangle.
Yeah, a right angle triangle. If this is the angle here, each of these sides have a name. This side is called opposite. This side? AD. J, adjacent. Oh my goodness, I can normally spell this. And the last one, hypotenuse. Yes. Hypotenuse. TH? I don't think so.
I think it's the last one.
Hypotenuse. Hypotenuse. Adjacent. ADACENT. ADJACENT. Yeah. Yes, they're all spelled correct. I know, I'm surprised too. Okay. So, we have these three fractions that are important to us. In total, there's actually how many comparisons you can make here? There's actually 9. You could do something like look at opposite over opposite, but of course that's silly because that's always 1. You could look at opposite over adjacent. You could look at opposite over hypotenuse. adjacent over opposite, adjacent over adjacent, adjacent over hypotenuse, hypotenuse over opposite, hypotenuse over adjacent, hypotenuse over hypotenuse. Three of those are stupid. Which three? This one is stupid, this one's stupid, this one's stupid. Three of them we'll look at this semester. We'll look at opposite over adjacent, opposite over hypotenuse, and adjacent over hypotenuse. But these three we'll look at in semester 2. It's these three here we'll look at now in semester 1. So these three ratios, they all have names. So the first one I'll do is this one here, which is called the sine of A, and that is the opposite side divided by the hypotenuse side. And the next one I'll do is the cos of A, and that's the adjacent side over hypotenuse. And lastly is the tan of A, which is the opposite side over the adjacent side. And these three will be important for us because they're, well, I'll write them down and we'll do some examples. So if you can just note this. There are ways to help you remember this. So this one is SOHCAHTOA. Sine is opposite over hypotenuse. Cos is adjacent over hypotenuse. Tan is opposite over adjacent. Correct. Okay, can you write this down?
Can you write
the word?
the word so? So.
I'm just glad I'm off next week. No, trust me, I'll be happier. Trust me on that. Okay. Do you have that? Yep. So, let's have a look at an example here of this. Let me draw a triangle. So this triangle, this side is 30 degrees. This length is 1. This length is 2. And this length is root 3. And if you didn't know that that was root 3, you can use Pythagoras and you'll get root 3. Anyways, it doesn't matter where this triangle came from. I'm just giving you this triangle. What's sine 30 if you look at this triangle? It'd be root 3 over 2. If you go take out your calculator and type in sine 30, no, that's wrong, Stephen. Sorry, I know my mistake, I'm sorry. That's angle's not 30, that's 60. If you type in sine 60, you get root 3 over 2. Okay, what is cos 60 on this triangle? 1 over 2. So let's have a look at cos 60. Yep. What's tan 60? Mm-hmm. Now, this angle here is 30. What's sine 30? Now, you have to be careful because sine 30, if the 30 is up here, 1 is the opposite side. So sine 30 would be 1 over 2. And cos 30? And tan 30? 1 over root 3. 1 over root 3, yeah? Opposite over adjacent. This is now opposite, this is adjacent, and this is still always the hypotenuse. Okay? But because this is built into your calculator, you can use your calculator to help you find missing sides. So for example, if I scroll down, here's the first example. $34,289 x. and we want to find x. Why can't we use Pythagoras? Yeah, you need the other side. So we can't use Pythagoras. But we can use SOHCAHTOA. So if this is the angle, what's this side called? Opposite. And this side? Hypotenuse. So which do I need? SOH, CA, or TOA? SOH, yeah. So I can say sine 34 equals x over 289. So that means x equals 289 sine 34. Which is 162 about. And if I wanted to, I could use Pythagoras to get this side. Or I could use another sine, cos, or tan. Okay, write this one down and we'll do another example. Got that? Okay. Let's see this one. This time I want the angle, and I have two of the sides. What is this side called compared to this angle? And this one? So I should be using tan, yeah. Tan A equals 171 over 140. So you have tan blank equals 171 over 140. And this angle is what we want. There's a special mode on the calculator to find the angle. So to find A, you have to use a special mode called tan inverse. And tan inverse works backwards. You give tan inverse the answer and it can give you the angle. So it's like a backwards process of tan. This is on your calculator. It's shift tan 171 over 140, and in degrees that's 51 degrees about. Is the answer here. If you know this angle, what's the quickest way to get this angle? 180 minus these two. Yeah. So this angle up here will be 180 minus 51 minus 90, which is 39, for example. Okay, write this one down. I have one more example to show you. Okay, next example. The last type I want to show you is this. And we want to calculate this without using the calculator. Now, just to be really clear, cos inverse, does that give me an angle or a fraction as the answer? Angle. And sine angle, does that give me an angle or a fraction? Fraction. So my final answer should be a fraction. Okay, good. Now, cos inverse gives me an angle. Agreed? It gives me the angle for the triangle whose adjacent is 4 and opposite is hypotenuse is 5. So from Pythagoras, what's this side? 3. We want sine of this angle, the angle we get from this. Well, what's sine of A here? No, remember we said the answer should be a fraction. Yes, what is it? 3 over 5. So this is the answer, 3/5. Now, you could actually check this on your calculator, but I don't know if it'll give me exactly the right answer. Sine cos inverse 4/5. Yeah, 3/5. But in the exam, often they want to see some proof that you worked this out. So even seeing this will be proof that you've done it without the calculator. Okay, can you write this one down? There's not much to write, but if you can write it down, please. Okay. Okay, you got that? These questions are very easy. I hope you can see that. So homework then, plus you're off next week, so I don't feel bad in saying homework is all. I think you can get most of them done now. They're so short. So snap to it.
When you're writing a degree as an answer, do you always just put in the actual numbers?
No, I was just rounding my answers to three significant figures. So, for example, if the answer was like 22.6, it would be 22.6 because that's three significant figures.
Because like in your answer sheet there are only numbers.
Are they all three digits though?
No, it's like if you look at the number 4.
It's 2 digits. You know what probably happened? I probably forgot to type in the question round to the nearest degree. So you can just do it like that.